Hey everyone, how are you doing? And welcome to a new video. As you can see, I'm not in the place where I used to be. I'm in a new place, actually a new apartment, since I moved recently from Berlin to Munich, which is in south of Germany. It is a very beautiful city here, very different from Berlin, different vibes, different people. Architecture actually is pretty much the opposite. But it's a great place, and we have a much bigger apartment. This is just my room actually, which I'm going to use as a studio, and it's pretty great. It's actually going to take a couple of weeks more for the moving to be finished, and then I will focus on making this room very cozy. Anyway, what I want to show you in this video, it is how to change shader parameters for every instance rendered by a GGL multiple. Every object rendered by GGL multiple in GL3, because it turns out in GL2 this is very easy. We can check it from the GGL multiple help file. If we go into a GGL multiple help file, we go into other parameters, we can see that this says like shader.zoom. It means we can change the zoom, a uniform parameter of the shader, using matrices. But it turns out in GL3 this doesn't work at all. So how can we do that? Well, we cannot use GGL multiple, we actually got to use gl.mesh with the instance mode, so which is something pretty cool. I didn't do any tutorials about it yet, I think. Maybe I did. But anyway, we are going to start from scratch here, and I'm going to show you how we can achieve what we want. For example, I'm using a custom shader here, which takes care of the instancing with gl.mesh, to draw a lot of planes, and every plane has different texture coordinates, so that they can display the texture frames emitted by JIT every plane displaying a different portion of the texture. Okay, so this is only possible through a custom shader. This is not possible with a simple GGL multiple unless we have a lot of textures and every texture has a different portion of the image. This will be another way of doing that. Then we will simply tell to all the objects which texture they have to use, but we don't want to create 20 by 20 400 textures. We actually want to use a single texture and then give a different texture coordinates to each object. So we can do that through the gl.mesh instancing using a custom shader, and we are now going to see exactly how to do that. So let's dive in. So first thing first, I want to have my world plus camera. So I'm going to just grab my snippet, but since I have already a world called main, in the other patch I will just change this to truth. And then also on the camera, truth. Right. So now what we want to do to create the instancing, we simply need first a shape to instance. And we need just a bunch of vertices actually, not directly a shape, but we're going to use GGL grid shape. Going to drive to truth, we're going to say automatic 0, and we're going to say matrix output, actually 2, because we want to get also the scale. So we're going to say scale like 0. Let's start with a scale of 0.2, okay? And then we want to set the dimensions of this, so how many vertices is going to have, to just 2 by 2, because we just need a plane. Oh, and indeed, I forgot to say shape plane. Okay, good. So now we need to send this to a GGL mesh, which also draws to truth, and it's of color white, I guess. Right, and it will need to have a shader, so let's give it a shader name already. Let's call it instance shader text chord, something like that. Good. The instancing will not work unless there is a shader that performs the instancing. Cool. So in order to do that, we need as well a GGL buffer, and we're going to give it type vertex at 0. So we just use one of the available buffers for the GGL mesh, one of the common buffers, which are vertex at 0, 1, 2, and so on. And then we say instanced is actually true. And then we can connect that to, for example, just the last output of GGL mesh. And let's then create a JIT gen, which we'll use to set the position of the instances. Okay, so it's like when we use GGL multiple and we have to set the position of all the objects through a matrix, which we can do with JIT gen. We will do the same here. Right, so let's create a matrix. Let's say that we want, I don't know, like 5 by 5. Oh, first is actually 3, float 22. And then 5 by 5 cells. So we will have 25 objects, 25 planes. And this is going to be the position of our objects. So let's actually send a bang here. Let's send a bang as well to this GGL grid shape. So it goes inside the GGL mesh. And as you can see, it appeared here on the world. And here, let's say simply that we want to have the signed normalized coordinates as the position of the instances. Okay, so it will just create a wall of planes, because this will go between -1 and 1 for the position of the single instances. Good, but since we don't have a shader, it will actually not work. So let's see how to make this work. Let's actually create a gl shader object. Let's give it the name instance shader text code as we give it to the GGL mesh, and then let's give it a file. Let's call it actually. Oh, I wrote this wrong. So let's call this file the same way. So instance shader text code .jxs, right? And of course it doesn't exist. So I double click on this GGL shader. I copy what's inside it. I go into Visual Studio Code. I create a new file, exactly, a new text file, yes. And I will save it with the same name that we just gave to the GGL shader, and must be in the same folder. So my patch is on the desktop, so the shader will also be saved on the desktop. Great. And then I said, I double click on the GGL shader, Command A, I copy all the content of this shader, and I just paste it inside the file I've just created. And then I say here, instead of plain text, I wanted the GLSL highlighting in Visual Studio Code, so it's going to show me the proper highlighting for the code. Now, in the default shader or GGL shader, we have a geometry program, which we don't need at all. So as usual, we just go here, we get rid of all this stuff, and we're just left with a vertex shader and a fragment shader. Okay, so that's great. Now, if I delete this shader and I recreate it and I double click on it, it will open automatically the Visual Studio Code file. So that's great. Now, in order to send and to use the instance position inside the shader, we need to do that. We need to create a new parameter and call it, for example, instance underscore position. And this is of type, actually is a vector 3. It's a vector 3, and it comes from the state from our vertex attribute 0. Okay, that's the buffer that we created in the patch. Is of type vertex attribute 0, so it's sending this data to the GGL mesh, which makes it then available for the shader. Okay, pretty cool. So now we have to bind it inside the shader as well. So bind param equal the name of the param, which is instance position, and we want to bind it to the vertex shader. So VP. Okay, cool. So now we need to declare it inside our shader. This is an input, vec3, and this is instance position. It's an input because this comes from a buffer. It's not a uniform that is equal for all the vertices of the shape. This is actually an attribute of the buffer, which means it's different for every vertex. That's why it's an input and not a uniform. Like, for example, the model view projection matrix is the same for all the vertices, so it's actually a uniform. But position, color, and distance position are different for each vertex. So cool. To apply the instance position, I guess it's going to be enough to just sum it to the position here before multiplying by the model view projection matrix. The position is a vector 3. Our instance position is a vector 3, so everything should be fine. And cool, it actually worked. After I saved the shader, it's actually working. So that's pretty awesome and great. So that's the most difficult part is gone. Now I want to show you how we can distribute the texture coordinates on all the single shapes instead of having every shape with a complete texture. Actually, let's create a JIT movie. Let's give it output texture 1 and let's say a movie file. We're going to use the chickens.mp4, and I guess this is going to work. Yes. Great. Oops, man, I haven't recreated the world. Cool. Let's maybe use a GTP window to check if it loaded the movie. Right, it seems to be working. Let's create a GGL texture, which is also going to draw to truth. And I'm saying that this should have rectangle 0. We want to have normalized coordinates. And let's give it a name. And we'll call it Pollo text. Pollo means chicken in Italian, so it's kind of a funny name. And there it is. I connect it to the output of JIT movie. We actually don't need this GPU window anymore. We know the movie is actually working. Cool. And I have to assign this texture to the GGL mesh. So I will go here and we'll say texture Pollo text. Great. As you can see, after I deleted the GGL mesh, I need to rebang here. Apparently, we don't need to rebang the position for the buffer because the buffer is attached and the GGL mesh will just fetch the values from within the buffer. So we don't need to rebang the buffer data. Great. So now it's not applying the texture because in the shader, we didn't define that the final color should be the color of the texture. We just say that this should be the GT in color, which for the moment is coming from the GGL grid shape. Actually, if we do something like this, we create a JIT unpack with a single output and we say jump 3. So it means we are only going to get the position, the vertices from these from the shape. We are just going to the vertex data, not the texture, not the color, and so on. You can see that the GGL mesh then uses the color that I used as an attribute, and it's not going to use the color that was passed by the GGL grid shape. Okay, so this was being overridden by the GGL grid shape. But if we just take the vertex data, then it's not going to get the color, so it's not going to overwrite this white one here. Cool. Now, in the shader, if we want to have the texture, we need to modify the shader and first declare that we have a texture to use. So let's call it Pollo text here. The parameter name, it's of type integer because this is just the index of the texture. And the default is going to be 0 because it's the first texture that we have. And we need to bind it as well. So inside here, I'm going to go here, say bind param Pollo text, and I'm going to program to FP because we want to bind it to the fragment program. We want to read it inside the fragment program. Cool. So inside the fragment program, which is our second program here, our second shader, we're going to say uniform. And this is a uniform because it's the same for all the vertices, right? And for all the fragments. We're going to say sample 2D, and this is called Pollo text, as we said. Now we need to sample this texture, and we need a couple of things to sample this texture. What we need is actually first the texture matrix. So after here, I'll just copy pasted from my previous code, but it's basically param name, and we can call it texture matrix 0, is a type mat4 and comes from the state, is a texture 0 matrix. We need to bind it, so again here bind param, and this is called texture matrix 0, and it's called, and this must be bind to the program, to the vertex program. Okay, it doesn't go to the fragment program, it goes to the vertex program because we want to use it in the vector program to multiply the texture coordinates so they will be correct. So inside here, this is another uniform because it's the same for all the vertices. And this is the texture, is a mat4, and this is the texture matrix 0. Cool. And finally, we need the texture coordinates. So let's go here and say param name text coord, and this is of type vector2. And this comes also from the state. This comes from the buffer of the GGL mesh, and we just call it text coord. Oops. It's not a semicolon, it's actually this slash and close to close the tag. And then we need to bind it. So here we go again, and we say bind param, and this is text coord, and we're going to bind it to the vertex program. So now we got everything we need. This is again an input because it's different for all the vertices, the text coord. So texture matrix, text card, and then the texture itself. So inside the vertex program now, what we need to do, first we need to pass the texture coordinates to the fragment shader. So inside our structure that goes out to the fragment shader, and this I covered in a couple of tutorials already, we say back text code 0. We call it text code 0 because it's relative to the first texture that we assign to the gl mesh, because we could have more texture and all of them will have different texture coordinates. So here then we say jit out dot text code 0 it's equal to our matrix, so texture matrix 0 multiplied by a vector that contains on one side our text code, this will be the x and the y, and then a 0 for the zeta, and then a 1 for the w. So don't ask me why there is a 0 and a 1, but this is just the way to go, otherwise it will not work. And this is actually a vector 2, so we can... We need to pass the text code to the fragment shader as a vector 2, so we can enclose those in parentheses, this whole operation, and then get out a vector 2. Now we need to go in the input structure of the fragment shader and just copy this line. Okay, so this is going to be the text code that comes from the vertex shader. So now we are ready, I guess, to sample our texture. So inside here we can say text color, it's equal to texture. There's some strange kids outside my window, which are making some weird noises. Nice kitties. And then we sample Polo text by using the jit in, which is the name of our struct. You see it's called jit in dot text card 0, right? And then we multiply, I guess, our jit color by text color. So let's see if something is happening here, and no, because we don't have any text code buffer. So we don't have any text code data for the gl mesh. So we can use again the jit unpack. We unpack now other 2 planes from the input matrix, but we need also then to apply an offset, which is 0 for the first 3 planes and going to be 3 then for the other 2 planes. And this is going to be the texture coordinates. This is just how the planes are distributed in a GGL grid shape matrix. So let me actually recreate it again. Cool. And as you can see, we now got the texture applied to all the single planes. But as we say, this is not what we want. We want that every plane has actually just a portion of this texture. So what we can do here then in the vertex shader is to divide these texture coordinates by a vector 2 which has the same dimensions of the number of elements we got, right? We got 5 by 5, so if I divide this by 5, it's just going to give us 1/5 of the texture coordinates. Let me actually... Oh, I'm on Mac now, I don't have Paint anymore. I wish I thought about this before, to an application to show you, to paint stuff, to show you things. But okay, this is basically just 1/5 of our texture. So basically, if this will be our texture, and this is divided by 5 by 5 blocks, we are just displaying basically this block here. Actually, is the one on the bottom. Okay, we're just displaying that because we divided the texture coordinate by 5. So now what we want to do is to add to those texture coordinates an offset that will allow us to every time display a different portion of the texture. So this offset we can pass from our JIT gen, create a second output, and we can use the normalized coordinates for the offset. So this will give us a number that go from 0 to 1 for each cell of this matrix, and then we can pass them into a different GGL buffer, which will connect to the second output, which is also instanced, which means it will pass its values to every different instance of GGL mesh, so every one of the different instances we created. So in order to make this work now, we need to go in the shader, copy this line here and say this is actually vertex attribute 1. Instead of instance position, we will call this instance text, let's call it text card offset. Okay. And then we need to bind it. So here we can copy that and bind it to the vertex program. And then here this is another input because it's different for every vertex, actually for every instance in this case. So we need to say, we need to call it, it's a vector 2. Actually it's a vector 2, so I have to modify it also here. It is a vector 2. It's an input. So what we can do is to now to add that to the texture coordinates before we multiply them by the texture matrix. So let's see what we get with that. And boom! As you can see, it's kind of working because it gave us a different image, a different portion of the texture for each instance. But there is something wrong, and that's related to our offset, because we are dividing by 5 our texture coordinates, and then we are adding 0.2, 0.4, 0.6, 0.8, and to the last one we are adding 1 complete, which should actually be a different scale, and this should be the dimensions. So inside the jitter, we can write 1 divided by the dimensions, and then we need to scale the normalized coordinates between 0, they go between 0 and 1, and then we need to scale that between 0 and this number. So actually 1 minus this number, exactly. That's how it is. It's kind of confusing, but if you think about it, it makes sense. Because we need to not to scale all the way like if we would add 1/5 every time. We actually need to add an offset of 1/4 every time. That's why we can scale it like this. So this should now work. Let me just check if I delete this buffer and recreate it. Oh, and actually the buffer should not be attached to the same input. That's kind of important, I think. So yeah, connected to 2 different inputs, now the offset is working. So this is all I wanted to show you. Then in my test patch, in the demo patch I showed you before, I also touched Fizz multiple to add a little of cool stuff to it, but it's not really necessary. That's kind of the main thing I wanted to show you, and that's it. If you have any questions about it, just ask me in the comments, and if you can put a like to the video, it will be great. Subscribe to the channel is much appreciated. If you want to get more patches from me and to have a more direct relation with me, you can join my Patreon, and you can join my Discord channel. There I'm always there basically talking with the Patreons, answering questions, we talk about jitter and so on. So thank you very much for watching, and I will see you in the next video. Hopefully the room will look a bit better by then. So have fun and see you soon. Ciao.